Okay, we're going to look quickly at the proof of the derivative of log base b of x. So here's the proof, the whole thing right there for you. And I'm just going to explain it kind of line by line here. We start out by just defining our function, y equals log base b of x, right? That's what we want to take the derivative of. So we use the definition of derivative, which is, of course, the limit as h approaches 0 of f of x plus h minus f of x all over h. So we plug x plus h into the function, and log base b of x is f of x, and so here's f of x plus h, and then f of x, right, all over h. The next step, the second step, we use a log property, right? The log property we're going to use is log of a over b equals log of a minus log of b, right? We have this right there, right? And we're going to change it into this, right? So a would be the x plus h, and the b would be x, so we get then x plus h over x, right? So that's how we get that, what I would call the second step of the proof in this version here. And this is, of course, the version I'll put on the quiz. The next step is pretty easy. We take what was dividing by h and we multiply by the reciprocal of h. So that's just a little algebra. No problem. Okay, in the next step, and let's see, I should start numbering these. So here's 1, 2, 3, 4. Those are the step numbers here. So in step 4, what we did is we multiplied by x over x, which is equal to 1. So we can put that wherever we want. And so we put it in basically right here. And when you're multiplying fractions, you can switch the numerators and denominators. I mean, you can switch the two numerators between the two fractions, and you can switch the two denominators. So we had x over x when we put x over x in, and we switch the 1 and the x because they're just multiplying fractions. It doesn't matter what order you go in. Then, since 1 over x is not affected by h approaching 0, in step 5 here, we take the 1 over x and move it out, right? So this 1 over x that was, it's getting a little crowded here, right there, we moved it outside the limit to right there. Okay, and that's the only change from step 4 to step 5. Step 6, we use another log property. So the other log property we use is that log of a to the b equals b log of a. And so then again, we're going in reverse. We have this. We have something multiplying by a log, which was the x over h. I'll do that in yellow so it doesn't get too confusing here, hopefully. The x over h, that's like b. And then we move it up to the exponent of the thing we're taking the log of, right? Meanwhile, and let's see, I missed this a while ago. This is something we did a while ago. I should head back here to step 2. We have this 1 plus h over x. Where did that come from? It used to be x plus h over x, and it got changed to 1 plus h over x. That's, of course, because we just distributed. We had x plus h over x. This is equal to, you divide the x into that x and the x into that h, so you get x over x plus h over x. If you think about it, all you're really doing is adding fractions. You have the common denominator, and so you keep the common denominator and you add the numerators. And again, this is sort of like in reverse. Because going the way the arrow is going, that would be the way you add fractions. We went in reverse, went to this, the x over x plus h over x, and x over x is, of course, just equal to 1. So that's what we get there inside the log in step 3, that is. Okay, the next step is we take this limit, which was out here, and we put it inside the log because it doesn't really affect the log except in that it affects the h's. Okay, so if it only affects the log by affecting the h's, we can just put it inside. It doesn't really make any difference. And now here's the ticket. What we have right here is equal to e. E being, of course, let's see, I'm almost out of room here. E, I'll just write it small down here. E is the limit as n approaches 0 of 1 plus n to the 1 over n, right? So this, what we have here, doesn't look exactly like that, but it's this very, very similar. In fact, it really is the same thing because we have we have basically one, in the definition of E here, we have a quantity where we've got 1 plus something going to 0, right? The h is going to 0. Sorry, this is an n, right? The n going to 0. So 1 plus something going to 0 raised to the reciprocal of that thing, which of course is going to infinity. It's getting bigger and bigger. And so here in our proof, we have 1 plus something going to 0, all raised to the reciprocal of that thing, right? And so that's equal to E, and so that's where we get this E down here at the bottom. Okay? And there's the proof.